We know that the solar system is constantly moving forward and that the entire solar system, along with all its components, is rotating in the same direction. It seems that no one has noticed, and apparently no one wants to believe, that the solar system moves this way only because a force is inevitably at work here, one that makes it possible for the solar system to move in this manner forever. But where does this force that drives the entire solar system come from? It is certainly not some nonsense like dark matter or dark energy. In fact, there are countless celestial bodies in the universe, each of which possesses gravity and thus forms a gravitational field. This means that the universe is permeated by countless gravitational fields. When an object passes through a gravitational field, its motion is impeded by that gravitational field. Under such conditions, it is impossible for a celestial body to continue moving indefinitely without the influence of a force. But where does the force that drives the motion of the solar system actually come from? A gravitational field does not merely slow down an object's motion as it passes through the field. The gravitational field, which rotates along with the object, pulls other objects within its sphere of influence, causing them to move in the direction of the gravitational field's rotation. We explained using a binary star system that the two stars propel each other in two orthogonal planes through their gravitational fields. As a result, they orbit each other, and each develops its own rotation. Rotation arises because the orbital velocity of each star is limited to a maximum value due to its inertia, while the gravitational field of the other star constantly exerts a force on it. To release this force, its direction must change, and the star's remaining, unrestricted freedom of movement consists of rotating around its own axis. This inevitably results in the star's rotation. The rotation of each star causes all its components to orbit around it. Let us now consider our solar system. Its motion corresponds exactly to that of a star in a binary star system. We can therefore imagine that our solar system could very well be a star in a binary star system. However, if that were the case, where would the other star or other sun be? Generally speaking, stars are luminous bodies. If there were a second sun, it would have to be visible to the naked eye. In our explanation of the sun, we also explained the phenomenon of the sun's heat. In fact, the sun's heat is not generated by a fusion reaction, as modern scientists assume, but by this rotation. This is because the resulting rotation causes the sun's interior to spin faster than its exterior, creating friction between the individual layers inside and generating heat. This means that this thermal energy is ultimately generated by the driving force of another star. In a binary star system consisting of two stars of different sizes, the smaller star receives more energy from the gravitational fields of the larger star than vice versa. Let's imagine that in a binary star system consisting of two stars of different sizes, if one of the two could not shine because it does not receive enough energy, then that would be the larger star, not the smaller one. This means that if only one of the two stars can shine, then it is the smaller of the two. We can certainly imagine that the Sun is very likely the smaller star in a binary star system. The reason we cannot see the second star could be that the larger star has a much greater mass than the Sun, but cannot emit light due to insufficient energy from the smaller star, the Sun. According to our rough estimate, the force, acceleration, acting on the solar system is approximately as follows. The following equation can now be used to estimate the position and mass of the second Sun.